Namaskar. The topic of discussion in this module is on fluvial landforms. The hydrological cycle is an everlasting process on earth. In this process, rainfall is the basic input coming into the surface. Flowing surface water is the result of total precipitation minus evapotranspiration and infiltration into the ground. The water flowing as a stream performs three kinds of geologic work as erosion, transportation and deposition. Hence, the running water is considered as one of the geological agents on earth. The word fluvius in Latin refers to river. The word fluvial is used to denote running water as a stream or river. The flow of water has a force, it has a velocity, it also has the power to generate power. There are many natural and dynamic processes happening along a river. Sometimes there may be severe floods along the river courses which can destroy everything along the flow path. Natural hazards are also caused by these streams. Flowing water has the ability to dissolve many soluble mineral substances along their way. Rivers and running water are considered to be dynamic geomorphic agents. Fluvial processes entail the erosion, transportation and deposition of earth's materials on the surface of the earth. The fluvial processes and fluvial landforms dominate the land surface all over the world. Understanding of the fluvial geomorphic process is an essential aspect in physical geography. Hence, the following aspects are highlighted in this section: streams and drainages, erosional work of streams, transportation by streams, erosional landforms and depositional landforms. Let us see the first part of streams and drainages. Streams are flowing water bodies. The flow of water starts after every rain. Rainwater also falls on all slopes of a land, gets collected and start flowing as overland flow. The flowing water merge along the converging slopes, join together and run as main streams. The main stream normally contain the cumulative volume of flow. The total water flows out of a single outlet is called as river mouth. The entire area encompassing the catchment zone up to the river mouth controlling this cumulative flow is known as a river basin. A river basin is the hydrological catchment zone of a river. It is also called as a drainage basin. It is a single major hydrological unit comprising all inputs from rainfall and all outputs as infiltration, surface runoff and river flow towards the sea or any other major confluencing point. A portion of the water that enters into the groundwater system beneath the drainage basin may also flow towards the outlet. The measurement of the river flow, which is also called as discharge of water from a basin, may be made by a stream gauge located at the basin's outlet. A drainage basin is an important hydrological unit considered in fluvial geomorphology. A drainage basin is the source of water and sediment that moves through the river system and reshapes the channel. Streams develop due to the erosive power of water. Slope of the land, nature of the rock type, structure of the rocks, extent of weathering and mass wasting processes on the land, climate and frequency of rainfall, all are responsible for the creation of a stream or they are responsible for stream development. Streams are classified based on their growth and development. Stream order is a method for classifying the relative location of a reach within the large river system. An ordering method proposed by Hutton in 1945 is the simple method for understanding the stream ordering methodology. Stream ordering technique assigns each headwater perennial stream an order of 1, and then at the confluence of two first order streams assigns the downstream reach an order of 2. In this method, the confluence of two second order streams results in a downstream side as third order stream, and so on. In a bigger river basin, the total streams may include several thousand first order streams, hundreds of second order streams, tens of third order streams, a dozen of fourth order and fifth order streams, and a few sixth or seventh order streams. Finally, the stream may end in 8th or 9th order when it reaches the confluencing point. Every stream has its own valleys. Valleys are common on the earth's surface. A valley is a depression on the earth's surface drained by water under the attractive force of gravity and exists between two adjacent uplands. Every valley has its own length and slope. The horizontal distance measured in the cross section in a linear depression between two adjacent upland is known as its length. The slope of a valley for a given reach refers to the difference in elevation between the upstream end to a point of reach along the downstream end. Valley development is a unique hydraulic process. It happens due to three concomitant processes as valley deepening, valley widening, and valley lengthening. Valley deepening is affected by hydraulic action, corrosion and abrasion of the floor of the valley, pothole drilling along the valley floor and at the base of the waterfalls, corrosion and weathering of the stream bed. Valley widening is accomplished by lateral erosion or planation by the stream in a valley, hydraulic action, corrosion, rain wash and sheet wash, gullying on valley sides, weathering and moss fasting, and the role of incoming tributaries. Valley lengthening may take place due to three ways as extension by headward erosion, increase in the size of their meanders, and extension at the confluence due to subsidence. The maximum downward limit for valley deepening is known as the base level of erosion. In some cases, the channel length may increase due to a meandering course of a river, but the valley length is short. A river is said to be starting from an youthful stage, runs through a mature stage, and reaches its old stage depending upon its age, length of flow path, density of streams, population of its streams, discharge volumes, and width of its mouth. All these factors contribute to the age of a river. A youthful stream is one that is undergoing initial development. Consequently, it has a steep irregular gradient, few tributaries or meanders, and a narrow floodplain. In addition, most of the erosion takes place in a downward direction. Next comes the mature stage. As time progresses and erosion continues, the stream gradient decreases. The number of coarse deflections on the other hand increases, so that the stream gets more meanders. Eventually, the degree of lateral erosion becomes equivalent to that of the downward erosion. This intermediate stage of development is referred to as maturity stage. The third stage is the old stage. The final stage of stream evolution occurs when lateral erosion takes precedence over undercutting or downcutting. These so called old age streams have very low gradient and wide floodplains. Every stream has its longitudinal profile and lateral cross sections. The longitudinal profile of a stream is analyzed to know the water surface slope. It helps to compute the velocity of flow and also understand the gradient. The transverse profile helps in identifying the nature of topographic floodplain and hydraulic floodplains. The actual water flowing zone in a river is called as the bankful elevation. The second part is related to the erosional work of streams. Moving water erodes material from the bed and sides of a channel. It transports the eroded material to a new location and then deposits them in one place. Material deposited by streams is called as alluvium. The ability of a stream to do these works is a function of stream velocity and discharge. A drainage basin is divided into three zones as zone 1, which includes the watershed areas of the drainage basin, zone 2, which includes the area of transfer, that is transportation, and zone 3, which includes the area of deposition. Erosion is the first part of the zone 1. Running water is capable of conducting headward erosion, vertical erosion and lateral erosion. Stream erosion is the detachment of material from the bed or sides of the channel. Approximately 95% of a stream's energy is used to overcome frictional effects imposed by the channel and internal molecular friction. This leaves only 5% of the stream's energy for vertical and lateral cutting. Flowing water erodes in three ways. First, flowing water dissolves materials from the channel, contributing to stream's dissolved load or solution load. Secondly, the impact of water or the hydraulic action on the sides and beds of the channel dislodges the materials and makes them available for transport as part of the stream load. The materials which are too heavy to suspend scoot and roll across the bed start eroding the channel by the action like abrasion. The rate of erosion depends on many factors like the climatic factors. This include the amount and intensity of precipitation, the average temperature as well as the typical temperature range and seasonality, the wind speed and storm frequency. The geological factors include the sediment or rock type, its porosity and permeability, the slope or gradient of the land, the nature of structures like tilts, faults, folds and weathering, the biological factors which include the ground cover from vegetation or lack of vegetation, the type of organisms inhabiting the area and also the land use. Sediments containing more clay tend to erode less than those with sand or silt. Hence, the impact of atmospheric sodium on erodibility of clay should be considered. The types of erosion by water are splash erosion, sheet erosion, rill erosion, gully erosion, stream erosion and bank erosion. Splash erosion is the detachment and airborne movement of small soil particles caused by the impact of raindrops on the soil. Sheet erosion is the detachment of soil particles by raindrop impact and their removal downslope by water flowing over land as a sheet instead of a definite channel or rill. The impact of the raindrop breaks apart the soil aggregates. Particles of clay, silt and sand fill the soil pores and reduce infiltration. After the surface pores are filled with sand, silt or clay, the overland flow of water begins due to the lowering of infiltration rate. Once the rate of falling rain is faster than the infiltration rate, runoff takes place. There are two stages of sheet erosion. The first is the rain splash, in which soil particles are knocked into the air by raindrop impact. In the second stage, the loose particles are removed or moved down the slope by broad sheets of rapidly flowing water filled with sediment known as sheet floods. This stage of sheet erosion is generally produced by cloud bursts. The sheet floods commonly travel for short distances and may last for short periods of time. Rill erosion refers to the development of small ephemeral concentrated flow of water which function as both sediment source and sediment delivery system for erosion on hill slopes. Flow depths in rills are typically on the order of a few centimeters or less, and slopes may be quite steep. These are very different hydraulic environments. Eroding rills evolve morphologically with reference to time and space. The rill bed surface changes as soil erodes, which in turn alters the hydraulics of the flow also. The hydraulics is the driving mechanism for the erosion process. It is dynamically changing the patterns of erosion and also the conditions of river systems. Thus, the process of rill evolution involves a feedback loop between the flow detachment, hydraulics and bed forms. The factors involved here are the flow velocity, depth, width, hydraulic roughness, local bed slope, friction slope and detachment rate. All of these vary with reference to time and space on the rill's evolutionary process. Superimposed on these interactive processes, the sediment load or the amount of sediment in the flow has a large influence on soil detachment rates in the rills. As sediment load increases, the ability of the flowing water to detach more sediment decreases. Gully erosion is another type of erosion. It is also called as ephemeral gully erosion. It occurs when water flows in narrow channels during or immediately after heavy rainfall or melting of snow in mountainous regions. A gully is sufficiently deep that it would not be routinely destroyed by any tillage operations. The narrow channels or gullies may be of considerable depth, ranging from 0.3 to 0.6 meters to as much as 25 to 30 meters. The valley or stream erosion is an important aspect. Valley or stream erosion occurs with continued flow of water along a linear surface. The erosion is both downward and headward. The downward happens during the deepening of the valley, and the headward happens during the process of extending the valley into the hillsides. In the earliest stage of stream erosion, the erosive activity is dominantly vertical. During this stage, the valleys will have a typical V-shaped cross section and the stream gradient is relatively steep. When some base level is reached, the erosive activity switches to lateral erosion, which widens the valley floor and creates a narrow flood plain. The stream gradient becomes nearly flat and lateral deposition of sediments become important as the stream meanders across the valley floor. In all stages of stream erosion, more and faster moving water is available to carry the larger sediment loads. In such processes, it is not the water alone that erodes, but also the sediments. In addition to the water, suspended abrasive materials or particles, pebbles and boulders can also act as catalysts for the erosive action. Bank erosion is the wearing away of the banks of a stream or river. This is distinguished from changes on the bed of water course, which is referred to as score. The third aspect is the transportation by streams. Once the surface material is detached from the channel, it can be transported by water very easily. Transportation is the movement of earth's material by running water. As particle size increases, so too does the velocity needed to transport it. The material transported through the stream is called as its stream load. Transportation involves the following processes. The first one is the traction. It refers to the load that is rolled along the bed of the river. The second one is the saltation. It refers to the load that is bounced along the bed of the river. The third one is the suspension. it refers to the load that is transported in a reverse flow through currents. The fourth one is the solution. It refers to the load that is dissolved by a river and then transported by it. The next one and the last one is the flotation, which refers to the material transported on the surface of a river. The larger pieces of material tend to be transported along the river's bed. As they get smaller, they can be transported in the current flow. Only the smallest bits may be dissolved and taken away in solution. The processes of erosion and transportation tend to make a river's load smoother and more rounded as it moves from the source place to the mouth. The stream load is composed of three components as dissolved or solution load, suspended load and bed load. Water has the ability to dissolve soluble mineral substances on the surface and also within the groundwater system. The dissolved load comes primarily from the groundwater seepage into the stream. The suspended load is comprised of sediment suspended and transported through the stream. Turbulent flow suspends clay and silt in the stream. Suspended load comes from material eroded from the surface bordering the channel and deposited in the stream, as well as erosion of channel itself. The stream capacity is the maximum load of a stream normally can carry for a given discharge. The stream capacity increases with increasing flow velocity. Turbulent flow occurs under higher velocity and it increases the water's ability to dislodge the materials from the bed or the sides of the stream. Bed load is the material which is moved across the bed of the river channel. Bed load is transported in two ways: traction, which is a scooting and rolling of particles along the bed, and the second one is saltation, which is the bouncing like movement along the surface. Saltation occurs when particles are suspended in the stream for a short distance, after which they fall into the bed, dislodging the particles from the bed. The dislodged particles move downstream a short distance where they fall to the bed, again dislodging the particles upon the impact. Deposition is the third aspect of a stream's activity. As the velocity of running water decreases, the ability of the stream to move the sediment through it also decreases. Hence, the heaviest particles will get deposited first on the bed. The relationship between particle size and minimum flow velocity for the three types of geologic work performed by the river water is to be understood. Let us examine the minimum flow velocity for erosion. Clay gets transported at any velocity. When velocity is high, all materials get transported. At the other end of the spectrum, the largest particles like sand require high flow velocities to erode them. Similarly, larger sized materials is harder to transport due to their weight. The deposition does not extend over to the very smallest sized particles also. The very smallest particles are easily transported even under low flow velocity and will also not settle easily. It is also evident that as the particle size and weight increases, it is very difficult to transport the material and the deposition will occur with a straight drop in the stream. Hence, the landforms which are generated out of these transportation processes are in the middle of the stream course. The fourth aspect is related to erosional landforms. The erosional landforms of the running water are very wide. They include river valleys, canyons, gorges, waterfalls, potholes, ravines, gullies and rills. Rills are shallow channels eroded by threads of turbulent flow. They are developed in the sheet flow. During rainstorms, rills erode headward on the steepest local gradient at faster rate. On open slopes, they tend to form parallel to one another and also form dendritic patterns of drainages. Rills are ephemeral features. They may be destroyed and recreated during major storms. The rills terminate at the base of slopes and thus they are not part of the regional drainage systems. Gully is the first order stream channel that develops on slopes at the upper reaches of a watershed. They carry ephemeral stream flow. Gullies are narrow and steep sided valleys. Gullies persist for years or decades, so they are more persistent than rills, but still not permanent features. The fifth part is related to the depositional landforms. The depositional landforms created by the running water are the floodplains, the alluvial fans and the deltas. Let us see the floodplains. These are the surface of low relief developed on the alluvium adjacent to a stream. Floodplains becomes the stream bed during flood seasons. A typical floodplain contains various features like point bars, overbank sediments, levees, levee crevasses, splay deposits, meanders, neck cutoffs and oxbow lakes. The depositional features of running water are controlled by several factors. Sometimes the gradient may decrease, flood waters may subside, or the water may get evaporated or soaked into the underground through porous materials. In any case, as the velocity decreases, the sediments are deposited. The heaviest and coarsest materials are deposited first, while the lightest and finest particles remain in the suspension for a longer period of time, travelling a greater distance from the source. The term alluvium is applied to all fluvial deposits with the exception of deltas. Streams carrying coarser sediments develop sand and gravel bars. These types of bars are seen often in braided streams which are common in elevated areas. Bars develop in braided streams because of reductions in the discharge rate. Two conditions often cause the reduction in discharge: reduction in the gradient of the stream and or the reduction of flow after a precipitation event or spring melting of snow and ice. Sand bars are the depositional features of a river. Point bars develop where stream flow is locally reduced because of friction and reduced water depth. In a meandering stream, point bars tend to be common on the sides of a channel bend. Dunes and ripples are the primary sedimentary features in streams whose channel is composed mainly of sand and silt. Dunes are about 10 or more centimeters in height and are spaced a meter or more apart. Ripples are only a few centimeters in height and spacing and are found in slow moving streams. Rossgen in the year 1996 proposed the following features that are created during the course of deposition by a river along its flow path: creation of point bars with few mid channel bars, numerous mid channel bars, side bars, diagonal bars, main channel branching with numerous mid bars and islands, side bars and mid channel bars with length exceeding 2 to 3 channel widths, and delta bars. These are the very important features which we can identify along the river beds. Streams with high sediment loads that encounter a sudden reduction in the flow velocity generally have a braided channel type. In a braided stream, the main channel divides into a number of smaller interlocking or braided channels. Braided channels tend to be wide and shallow because bed load materials are often coarse and non-cohesive. Meandering channels form when streams are flowing over a relatively flat landscape, and also it happens during the flow of a river over a broad floodplain. Floodplains develop when streams overtop their levees, spreading discharge and suspends their sediments over the land surface during floods. Levees are ridges found along the sides of the stream channel composed of sand or gravel. Levees are approximately 1/2 to 4 times the channel width in diameter. Floodplain deposits can raise the elevation of a stream bed. This process is called as aggradation. Oxbow lakes are the abandoned channels created when meanders are cut off from the rest of the channel because of lateral stream erosion. An alluvial fan is a large fan shaped deposit of sediment on which a braided stream flows over it. Alluvial fans develop when streams carrying a heavy load reduce their velocity as they emerge from mountainous terrain to a nearly horizontal plane. The fan is created as braided streams shift across the surface of this feature depending upon the sediment and adjacent river course. Any stream flowing into a standing water body normally creates a delta. A delta is the body of sediment that contains numerous horizontal and vertical layers. Deltas are created when the sediment load carried by a stream is deposited because of a sudden reduction in the stream velocity. The surface of most deltas is marked by small shifting channels that carry water and sediments away from the main river channel. These small channels also act to distribute the stream's sediment load over the surface of the delta. Many deltas are triangular in shape. Most deltas contain 3 different types of deposits as foreset, topset and bottomset beds. Foreset beds make up the main body of deltas. They are deposited at the outer edge of the delta at an angle of 5 to 25 degrees. Steeper angles develop in finer sediments. On top of the foreset beds are the nearly horizontal topset beds. These beds are of varying grain size and are formed from deposits of small shifting channels found on the delta surface. In front and beneath the foreset beds are the bottomset beds. These beds are composed of fine silt and clay. Bottomset beds are formed when the finest materials are carried out to sea by the stream flow. Run of water or overland flow of water has the ability to carry out destructional, constructional and life giving activities in every part of the world. Humans can also change the hydrology of rivers in many ways. Land use and land cover are the 2 important aspects to be understood. Fluvial landforms are very typical features on the surface of the earth. Understanding of the fluvial landforms helps in civil engineering, environmental engineering, structural engineering, town planning, urban planning, landscape designing and also the overland development of any country. Thank you.